Hey there everybody, welcome to today's lesson. Today we're going to be talking about how to find the difference between 2 points. You might be asking yourself, what does that have to do with the Pythagorean theorem? Well, I'm about to show you. Before we start, I want to make sure you know I'm going to show you question number 1. And maybe you're going to think to yourself, okay, I totally get this. I'm going to just go ahead and stop the video. Don't stop the video because I'm going to show you something new and very important in problem number 5. So make sure you at least see through to the end of problem 5 before you go on and do your assignment. Okay, let's get started right now. So the distance between 2 points. Step 1 here, put the 2 points on the graph. So we have 7, 3 and we have -1, 4. So 7, 3, let's go to 7 and go up 3. We've got it right there. And -1, -4. So I'm going to go -1 and then down 4. And for those of you guys who maybe don't have a printer, guess what? You can open up your Desmos graphing calculator, and this is super awkward. I'm going to put my other computer under here. Okay, so on your Desmos graphing calculator, that's just desmos.com/calculator, you can just write your ordered pairs like that, and it will show you where the dots are. And I want you to look carefully at how much you're zoomed in. You see how it's going 2, 4, 6, 8? I mean, that kind of works, but it's going to be easier for you if you can just count by ones. Like for me, this view is better because I can just go 1, 2, 3, 4, 5, because we're going to be counting across by units a lot. So make sure you have a zoom on here where you can count across and see how far it is from one point to the next when you're doing this. All right, so that's the Desmos view. Let me go back to the paper view. So what we need to do is find the distance between here and there. And I don't know, it doesn't look so obvious, does it? Gee whiz, how does this relate to the Pythagorean theorem? Well, I will show you how. It's kind of like when you draw the rise over run. What you want to do is make your little, I was going to say stair step, but it's probably better to say complete the triangle. And as you can see, this is going to be a right triangle. Here would be a leg, and here would be another leg, and this guy, which is what we were trying to figure out the length of, that's just the hypotenuse of the right triangle, right? Okay, so if you wanted to use your Pythagorean theorem, a squared plus b squared equals c squared, then this would be a, and this would be b, or you could switch those, it doesn't matter, and this would be c. So the question now is, can you figure out the length of a and figure out the length of b? Absolutely, let's count. Okay, for a, 1, 2, 3, 4, 5, 6, 7, 8. 8, and as you know, you have to square a, so 8 squared, plus, now let's figure out b. 1, 2, 3, 4, 5, 6, 7, b was 7, and as you know, you have to square b, so let's do 7 squared, equals, well, we don't know what c is, that's what we're trying to figure out, so let's just write c squared. So now we've got 8 squared plus 7 squared equals c squared, and we can just solve this. So we've got 64 plus 49. So 8 squared became 64 and 7 squared became 49. Now let's add these together. I'm just going to use my calculator here. 64 plus 49, we're going to get 113 equals c squared. Now how do I get that c by itself? We're going to square root both sides. So you're going to do that little symbol right there, square root. So that's mine right there. So it came up as a square root. You're doing the square root of 113 and you're going to get, oh, my calculator's a genius. It tells me the square root of 113 is the square root of 113. Fortunately, there's another button I can push here and it comes up with this, 10.63. We're going to just take it to the nearest tenth, so let's do 10.6. 10.6 equals c. And then you're done. So that's how you use the Pythagorean theorem to find the distance between 2 points. Now, remember, don't stop this video even if you're like, oh yeah, that's easy, I got this. I'm going to show you something new with example number 5. So we're going to get to that in a second. Feel free to fast forward to it if you want. Let's do number 3 first, just to practice this a little bit more. So for 3, you have 6, -7. So I've got 6 here, going down to -7 is there. And then 3, -5. So 3, let's see, 3, -5 is right here. Okay, these points are a lot closer together. We're still going to do it the same way. Let's draw the legs of the triangle. We're going to have a leg here, and we're going to have a leg here. And then the hypotenuse is the distance between the two. So we're just going to use Pythagorean theorem to solve it again. So what's the length of this leg here? You can just count. 1, 2. That one's a 2. What about this other leg? 1, 2, 3. Looks like that one is 3. So we'll call this one A and this one B, but if you wanted to do it other way around, totally fine. So A squared is going to be 2 squared. And B squared is going to be 3 squared. And then this distance is going to be C. So I'll just write C squared because we don't know what it is. So 2 squared simplifies to 4. 3, oh, I wrote 3 cubed. Silly me. It should be squared. You guys know that. So 3 squared simplifies to 9 and equals C squared. So 4 plus 9, that's just going to be 13 equals C squared. Now to get that C by itself, we have to square root both sides. And I don't know what the square root of 13 is, so I'm going to grab that calculator again. You can also use your Desmos scientific calculator, or like your iPhone calculator turned on its side will give you square roots. Okay, and it looks like it's going to be 3.6 for the measurement of C. All right, so the distance here is 3.6 units, whatever they are. All right, now let's go to number 5. So number 5. Let's go ahead and put these points on the graph. 5, negative 8. 5, 6, 7, 8. 5, negative 8 is going to be there. And negative 8, 6 is going to be here. Okay, this is going to be a big triangle. So we're going to draw all the way down here. Let's see, it's going to meet up right about there. There we go. So those would be the legs of our triangle, and then the distance between them is this. All right, so this is a lot to count. You can definitely count and find the length of the legs here, the length of this leg, and count over and find the length of this leg. But is there maybe a faster way to do it? Could you just like figure out maybe the difference between, let's see, this one's at 5 and this one's at negative 8 over here. So as far as x's go, this one starts at 5 and then we go over to negative 8. So you could just subtract those to find the total distance, right? You could literally do 5 minus a negative 8. So as you know, minus a negative turns into a positive. So that's the same thing as 5 plus 8. And that's going to be 13. So the distance between here and there, in other words, the length of this leg, is going to be 13. And what about from here to there? How would you figure that out? Well, let's figure out the distance, the difference in the y's. So we have 6 here, and what do we have down here? We have negative 8. So 6 minus negative 8, make sure you get both of those negatives in there. You're going to have to turn that into a positive because when you do minus a negative, it just turns into a plus. 6.4, 6 plus, not 8, my goodness. There we go. 6 plus 8 is going to equal 14. So we know that this leg is 14 long. And guess when this is really going to come in handy? When you don't actually have a graph given to you. What if we just gave you the 2 points and we're like, okay, there you go. Figure out the distance between those two. Well, you know what? You can do that because you know how to subtract. So let's just take a look at how you would subtract if all you had was this. You would just take an x and subtract another x to figure out the change in x. Do you guys know this terminology, delta x? Whenever you use a triangle like that and call it delta, that just means the change in something. So when I say delta x, it just means the change in x. So you would go 5 minus negative 8. Or you could go negative 8 minus 5. Either way, it's going to turn out fine. So you're going to do the change in x for the first number, and then you're going to do the change in y for the second number, and I'm going to write delta y. So for the change in y, you're just going to take negative 8 and subtract 6. Or you could do 6 and subtract negative 8. Either way. But this is going to be kind of like your special Pythagorean theorem for finding the distance between 2 points. Your distance, your c squared, is going to equal, well, the change in x is going to be your a, so we're going to say a squared. And the change in y is going to be like your b, so we're going to say change in y squared. Are you with me? So the c, the hypotenuse, c squared, is going to be equal to the change in x squared, because we have a squared in our Pythagorean theorem, right? So if the change in x is a, then you have to do the change in x squared plus the change in y squared. All right, so what was the change in x here? It was 13. What was the change in y? It was 14. Let's write this out a little bit more neatly. So c squared is going to equal 13 squared plus 14 squared. And again, can you just put it on the graph and count? Yes, you can, as long as there's a graph there. If there's not a graph, it might be easier to know how to subtract. Okay, so let's keep solving this. 13 squared is going to be 169. Oops, I meant to write 169. And then 14 squared, I think, is 196. You're going to add those two together, and then you're going to square root them, right? I'm just going to do that all in one step. I'm going to do the square root of 169 plus 196. And all in one step, it's going to tell me my distance is 19.1. So C equals 19.1. So now there's this big fancy formula. You want to see it? This is called the distance formula. Isn't that impressive? Boy, that looks like a mess, doesn't it? D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's a lot. What does this mean? All that means is this right here. You have your a squared plus b squared equals c squared, except instead of a squared, we're just saying the change in x squared. And instead of b squared, we're saying the change in y squared. So it's the same thing. And if you understand how to use this, that's really all you need to know. I kind of think memorizing formulas is overrated. It's not my favorite part of math. I don't think it's that critical. Unless, of course, you have like that mad scientist, crazy math genius thing going on and you want to write formulas like this on the chalkboard and look really cool. I mean, there's definitely a place for that, let's face it. Okay, so this is your official distance formula. And I'll show you how to use it in the next problem. But I want to emphasize that this is just the same exact thing as this. And this is just the same exact thing as what you've been doing all along, which is a squared plus b squared equals c squared. Okay, let's try another problem. All right, so number 7. You have negative 7 comma 0. Let's put it on the graph. And then you have negative 2 comma negative 4. That's going to be right here. Okay, so we still need to figure out this, but instead of drawing the whole triangle and everything, let's just try subtracting. So negative 7 minus negative 2. So what am I doing right here? I'm taking this x and I'm subtracting this x from it. So negative 7 minus a negative 2. Well, we know that minus a negative becomes a plus. So let's just do that. Negative 7 plus 2 equals negative 5. Okay, so our change in x equals negative 5. Now, if you had subtracted it the other way around, you would have gotten positive 5. Does it matter? It really doesn't matter. Why? Because we're just going to square it anyway. And when you square a negative 5 or square a positive 5, they both turn into 25. So it really doesn't matter. Now let's do the change in y. So we're going to do 0 minus negative 4. And that minus a negative turns into a plus. So you're going to get 4. So the change in y is 4. So now let's write our kind of modified Pythagorean theorem again. Change of x squared plus change in y squared equals, you can say c squared or you can say distance squared. I'm just going to say stick with c squared. But if you ever see this variable d, that's going to represent distance also, kind of like in the distance formula, okay? All right, so let's plug into that formula. We'll just use this space down here to do that. So our change in x was negative 5. So negative 5 squared. And our change in y was 4. Plus 4 squared equals c squared. All right, let's do the math on it. Negative 5 squared is going to be 25. 4 squared is going to be 16. And what is 25 plus 16? It looks like that comes to 41. And then you're going to square root both sides. And you're going to get something. My calculator, silly calculator. Okay, 6.4 equals c. All right, so that's going to be your distance from here to there. And as far as the legs go, if you had drawn the legs, what would you have gotten? Let's see, 1, 2, 3, 4. You got 4 here, and so that's what we have there. And you get 1, 2, 3, 4, 5, and that 5 is the same as you got there. Now, you may be saying distance can never be negative. You're right, it can't be negative. We're not going to worry about that -5 though, because it all comes out in the wash. As soon as you square it, it becomes 25, so it really doesn't matter whether you have a positive or a negative there. Okay, I want to show you how to use the distance formula with this guy also, so that you can see how it's really just the same thing. So distance formula, I'm going to write this right here. Distance equals square root of, okay, x2 minus x1. So we're going to call this one x2. Let me just label these all. So this is x2 and y2. This is x1 and y1. I can't seem to number things correctly today. I'm so sorry. So x1, y1, x2, y2. All right, so x2 minus x1 is going to be -2 minus -7. Whatever you get there, you're going to square it. Okay? And now we have to add to that y2, which is -4, minus y1, which is 0. Okay, that's nice. And then whatever you get there, you square it. And let's continue our square root radical all the way over the top. And let's simplify. Distance equals, so -2 plus 7, because those two negatives turn into a positive, is going to give us 5 squared. Okay, we took care of that. Now let's do -4 minus 0. That's still -4, right? So -4 squared. Finish out your radical there. And now d equals, let's simplify some more. 5 squared is 25. Plus rather, and then -4 squared is 16. By the way, are you starting to see the similarity to what we did over here? It became 5 squared and basically 4 squared, and we have basically 5 squared and 4 squared here, which becomes 25 plus 16, which is exactly what we have here. And then the next step would be to add 25 and 16, and you're going to get 41 under the radical. So the final step is to take the square root of 41, regardless of which way you do it. And so we know square root of 41 is 6.4 because we just solved it over there. So 2 different but essentially the same ways to get the same answer. Okay? You may feel like you've had enough practice, and that's great. You're welcome to stop this video and go do another problem or work on the evens, which is your assignment. But if you want to see another one solved, stick with me. We're going to do number 9. Okay, so number 9, -2 and 2. Okay. And -6, go to -6, and then down to -8. So here's -5, 6, 7, 8. Okay, so you could do it by drawing the legs and counting. Let's just go ahead and do it that way. 1, 2, 3, 4 for this one. This one's 4. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is 10. All right, and you're looking for the hypotenuse, which is right there. So using the legs and our formula a squared plus b squared equals c squared, you're going to have 4 squared, because that's one of the legs. I'm just going to call it a. If you wanted to call it b, you could, no problem. So that's 4 squared plus b squared, so that's 10 squared, equals, I forgot to label that hypotenuse c. We're just going to leave it as c squared. So we have 4 squared plus 10 squared equals c squared. Let's go ahead and simplify. 4 squared becomes 16, 10 squared becomes 100, and we'll leave c squared as c squared. Add those two together, you get 116 equals c squared. And now to get rid of that square root, to get rid of the square rather, you have to do the square root. So square root both sides. And it looks like you're going to get, whoopsie, there we go. We'll put 116 in there and make sure it gives you a decimal. 10.77. I'm going to round that to 10.8 because we're doing it to the nearest tenth. So 10.8 equals C. Okay, so now what if you were going to do it without the graph? That's always the question, right? Well, what if they just gave you that? I'm going to rewrite it down here. So -2, 2. I'm writing it down. You'll see it in a second. And -6, -8. Okay, I've just copied it over right down here. Now let's use this formula right here. okay? Change in x squared plus change in y squared equals c squared. So you can see it's very similar to the Pythagorean theorem. In fact, it pretty much is the Pythagorean theorem, just with different labels. All right, so how much did the x change? Well, that's a good question, right? It's easy to see when you draw it, but what about if you're just given all these numbers? Well, first of all, which ones are the x's? You've got the -2 and you've got the -6. How much change was there? Well, whenever you're trying to figure out change, you're going to need to subtract. So let's just subtract them. Doesn't matter what order you go in. So I'm just going to start with this one, -2 minus a -6. Make sure you get that double negative in there because you're subtracting a negative. So you're going to have two negatives in a row. Those two negatives in a row are going to turn into a big plus, and -2 plus 6 is going to wind up equaling 4. And it would have been good for me to label this. This is the change in x. So the change in x equals 4. Now let's figure out the change in y. I'll put squares around the y's. So the y's are always the second one in the ordered pair, right? To figure out the change, you still have to subtract. So let's go 2 minus -8. Oh, we got two negatives in a row again there. So let's make them into a nice big positive. 2 plus 8 is going to equal 10. All right, so our change in y is 10. And I just want to show you really quick that when we were up here, 4 and 10, those were the two numbers we used for a and b. 4 and 10 are the same two numbers we're going to use for what you would call a and b here. All right, so when we plug them into the formula, it's going to start to look exactly like that other example. 4 squared plus 10 squared equals c squared. Where did I get that from? Just to be sure, the change in x was 4. So I plugged that in there, made sure to square it just like the formula says. And the change in y was 10. Plugged that in there and I made sure to square it just like the formula says. So that's how I got this right there. I'm not going to keep solving this because you just saw me do it up here and it would be exactly the same. I am going to show you also with the distance formula, so if you're interested in that, stay tuned. We're going to do that right now. So the distance formula is this guy. So d equals the square root of, okay, let's do x2 minus x1. It doesn't matter which one you subtract from which, so whatever order you want. I'll do -2 minus -6, -2 minus -6 squared. So I just subtracted one x from the other and I squared it. And then we're going to add to that 2 minus -8. 2, make sure you get that double negative in there because you're subtracting a negative. So 2 minus -8, don't forget to square it, and then you're just going to finish drawing out that radical sign. Okay, let's simplify now. We don't need this anymore. D equals the square root of, well, -2 minus -6 is the same thing as -2 plus 6, just like we were talking about there, and it's going to equal 4. And we're still going to have to square it, plus, let's see, 2 minus -8 is the same thing as 2 plus 8, just like it was right there. So that's going to be 10 squared. Finish drawing out that radical. Let's keep simplifying. D equals the square root of 4 squared becomes 16. 10 squared becomes 100. And then you're just going to add them together for 116. And from that point, you just throw it in the calculator, and you're going to get the square root of 116 equals 10.8, which is just the same as what we got right up here. Okay, so there's a little overview for you of the distance formula. If you have any questions, let your teachers know. We'd love to hear from you guys. Thank you so much for watching, and I'll see you next time. Bye.